Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Clemert, leader of the Wireless Center of Excellence here at Cisco. And in this week, episode 15, we're going to be discussing Cisco Ultra Reliable Wireless Backhaul. I'm excited. I would like to welcome back to the show a couple of our special guests today. Welcome back, Ray Geyer from Pittsburgh, Pennsylvania. How's it going, Ray? Good to see
Good.
you.
How's everyone? Nice to see
Good.
you.
Good. Yeah, thanks for joining us today. And also Mr. Dan Davis from Portsmouth, New Hampshire. How are you doing, Dan? Thanks for joining us today.
I'm doing well today, Dan. Good to be back on Unplugged.
Excellent. Thanks for being here. So before we get rolling here, just a couple of quick reminders about the show today. If you have questions, you can use the Slido panel. You'll see the QR codes up for joining the Slido as well if you'd like to do that. If you're joined via WebEx, you'll see the Slido panel on the right-hand side of your screen. You can submit your questions there. If you are tuned in via YouTube, you can see the Slido link below the video stream. Join there with the passcode that's right there. And don't hesitate to ask any questions. We have people standing by ready to answer those questions on the broadcast. And if we have time, we may take a couple live during the broadcast as well today. So as usual, the session is being recorded and will be available on our YouTube channel, which is youtube.com/@GetUnplugged. And I would also encourage you to go out there and subscribe if you haven't already. If you are, thank you. Then that way you'll be notified when we do go live with future episodes and future content. All right, that's it for the reminders. And now on with the show. Ray, take it away.
Sure. Welcome, everyone. Today, we're going to move outside the box just a bit. We're still going to talk wireless, but not exactly Wi-Fi. So Dan Davis has joined us today to give us a better understanding of what we call this Cisco Ultra Reliable Wireless Backhaul, better known as CURWB. So, this is not Dan's first time on Unplugged. So, welcome back, Dan.
Hey, welcome, Ray. Good to be back.
So this is our agenda for today. We'll go over what's in the name of CURWB. Where did it come from? What does it mean? We'll go over some use cases. And we'll compare, the CURWB technology to the traditional Wi-Fi. So within CURWB, there are kind of two, pieces of it. There's the fixed side, and then there's the mobility, the fluidity side. So we'll get into each one of those during this presentation. So just a little background. So Cisco has a dedicated IoT group that covers, these specialized products, for very specific, unique use cases like underground mining operations or an automated manufacturing facility. Very specific use cases. Then within IoT, there's an engineering team that it has the knowledge to answer questions about these specific use cases. So, for example, let's say I have a Caterpillar 797 heavy haul truck, and I want to put wireless equipment on there. So what base station do I need? What antenna type? Where should I mount this antenna? What's the vibration rating required for this installation? These are the questions that engineering team can answer. But when we're talking CURWB, this falls under that IoT group. So just a little background there. So let's get into it. So Dan, help us understand, what does the name CURWB mean? What does the ultra reliable wireless backhaul mean? Where did we come up with that? What does that mean?
Yeah, that's a good start, Ray. Before I head in there, though, I just want to reinforce what you said, that for us in the IoT group, knowing your business is our business. In fact, during the pandemic, I was quite curious on the supply chain issues, and we had a guy, Don Levin, come on, and he probably did about 6 hours of content just on ports and terminals. So definitely an asset of that group. But to the name, here is kind of the breakdown of the name. And if you look at it, the first letter C is Cisco, and then we've got ultra reliable wireless broadband. So let's dissect the ultra reliable in the beginning here. And I'm going to make a parallel to the private 5G side. If you look at private 5G, there's three pillars that make up this technology. And on the bottom right, one of them is ultra reliable and low latency communication. So if you're a consumer and you're out shopping for some way of outfitting maybe an open pit mine, maybe you've got some automatic guided vehicles moving around a manufacturing facility, and you think private 5G might be a good fit, well, through that Google search, you might very well end up also finding the CURWB product. And, CURWB can, in some cases, also do the same thing that private 5G is doing. There's comparisons that can be made there. And today we're not really going to get into that, but just to give you a little bit of idea of this name and, why marketing at Cisco kind of named CURWB as they did. The other piece of it, the W and the B in the CURWB, that would be, wireless backhaul. And, during the pandemic, they did quite a bit of wireless backhaul. It was the digital divide. I'm showing a little bit of a graphic there where you've got, a centralized school district, and then you've got outreach areas that are typically, say, students' houses who are working from home. And we're able to bridge those houses back to the centralized school. And in this particular case, the CURWB team was using Wi-Fi as well. That was the actual connectivity for the student. And a lot of times that was Meraki. So Meraki would provide the Wi-Fi, and then CURWB would provide the backhaul. And, that's the fixed piece of CURWB, but there is also the mobile side, which, I think the mobile side is where CURWB really has a definite industry advantage. And I've got just a graphic there showing kind of the moving bus. That could be a bullet train. That could be a autonomous haul truck, like Ray mentioned, in a mining operation. But mobility and, keeping connected and staying connected, low latency, that's certainly one of the assets of CURWB.
All right. Well, that helps, Dan. So, just to build off of the, what you just said, what can we get into more of the, what applications and, specific use cases we can use the CURWB product for?
Yeah, I think that's a good starting point. I can show you here. So let's divide it into two parts. On the left-hand side, we're going to have what we call the fixed. And a lot of this is point to point or point to multi-point links, wireless backhaul, if you will. And then on the right-hand side, those are the moving assets. But starting on the left, physical security, they've done an awful lot of work connecting cameras. And, whenever I go outside now in a public area, I'm always looking for, okay, where are the cameras? Teach my kids the same thing. And they're out there. There's a lot of them out there, and we are doing a lot of connectivity to those cameras that have power, but no data connectivity. And I mentioned the digital divide. Smart cities, another good example. We recently did a project for a city out in Utah connecting all their water tanks back to the town municipal building to understand, what is the current water level of each of these tanks spread out around the mountain valleys. Sure. And then on the mobility side, on the right-hand side of this, gets a little bit more interesting. I think rail is a great example. In the United States, we've got some rail. In Europe, it's a lot faster, 200 plus miles an hour. Japan is certainly known for that. And we're connecting these rail lines, giving them seamless connectivity, moving at over 200 plus miles an hour. Mining is an excellent one. Mining, if you think about an open pit mine, very dynamic environment. The earth is being moved constantly. And what they'll do is they'll take small trailers and they'll put them out strategic little sections of the mine so that the autonomous vehicles like the haul trucks can remain connected. And they're always moving these trailers. So there's multiple point-to-point links, multiple hops, and a mobility component in that as well to make sure these guys can still stay connected and run the business. Drones. We've got a recent project where we're connecting drones to inspect high tension power lines. And we're doing that with CURWB. They're remote, so it makes sense for the power companies to do this. And theme parks, I'll tell you what, A theme park is really it's an automatic guided vehicle with people on it, making it a little bit more interesting. There's a lot of safety concerns there. Timing and latency very important on those theme park rides. So lots of different use cases.
Yeah, I've seen the rails and the mining and even the theme parks. That the drone thing I just find fascinating. That I mean, I would not. I mean, it's a completely viable, excellent solution. I just one thing I would just never think of, and that's it's a reality today. It's impressive. So, I mean, we've talked these use cases, but haven't we been using Wi-Fi for these use cases for years now? I mean, we have, like you mentioned the point-to-point bridge, and we have the 9124. We have pervasive Wi-Fi all over the place in the enterprise and distribution centers and warehouses. Can we get into some of the similarities and differences between the CURWB solution as in the in Wi-Fi?
Yeah, right. That's a good call out. So we at Cisco acquired CURWB. It used to be called Fluid Mesh back in 2020. And when you acquire a company, there's certainly some overlap, and we've got some overlap here. And since this is unplugged, it's mostly a Wi-Fi channel. I think that's a good call out. I've got it tabled up here, so I'm just going to go through these columns and talk a little bit about the differences between CURWB and Wi-Fi. I think it makes for a good baseline, especially for our unplugged audience. Let's start off with spectrum. They're both unlicensed spectrum. You can contrast that to private 5G, which in the United States is going to be CBRS. That is going to be, I'll say, lightly licensed. You may pay a fee for that. You may not, but you're going to have to go through the applicant process. With these two technologies, that's not the case. Frequency bands, next column. CURWB, formerly called Fluid Mesh, they did have a 4.9 gigahertz offering, which, that was kind of nice because every once in a great while you'd run into a scenario where 5 gigahertz wasn't going to work. So you had a little bit of spectrum and 4.9 that could be used if it was public safety. Now, today, the product only supports that in Japan, but it's something that's on the roadmap. I think I'd like to see that be brought in. It's just a matter of when. Okay. So now, when you look at Cisco Wi-Fi, we've always had 2.4, right? That's how Wi-Fi started. But CURWB has never used 2.4. CURWB has really been mostly a 5 gigahertz product until 6 gigahertz, came into the mix recently. So CURWB will certainly be supporting 6 gigahertz with the AFC restrictions. And, Cisco Wi-Fi, of course, will take advantage of that new spectrum as well.
Dan, let me interrupt you real quick. So I see, the CURWB, like you just mentioned, CURWB and Wi-Fi both use the 5 and 6 gigahertz spectrum. I mean, they're operating in the same space. Is that okay if you can, if you have them running both in the same, sharing the same spectrum?
Yeah, fair question, Ray. So it's physics, right? I mean, you're not going to be able to have two channels operating side by side, but what we find is that they can't operate under the same roof. We often have CURWB operating within a Wi-Fi environment, and it takes a little bit of channel planning. You're not just going to go in and turn up both products. A little bit of spectrum analysis needs to be done. You need to say, okay, I'm gonna take a couple 20 megahertz channels out of my Wi-Fi 5 gigahertz channels, and I'm going to use those for CURWB. Or maybe I'm going to use just one channel for CURWB. CURWB doesn't typically take a lot of bandwidth, and we can usually channelize it and have them operate in harmony together.
Okay, thank you.
Sure. So next column, 802.11. They all use Wi-Fi chipsets. It might be Qualcomm, it might be MediaTek, might be Broadcom, but all Wi-Fi at the the chip level. Where things start to deviate a little bit is CURWB. Once you get into that layer 2, the top of the layer 2 MAC layer there, that's when CURWB starts to change things a little bit. To give you an example, for instance, a CURWB radio is operating as a client radio, is not going to do like an 802.11 reassociation when it moves from one infrastructure AP, one infrastructure radio to the next. And it's a good thing. It's different. It's been optimized and changed, but it's been done to support some really unique use cases. Okay, and Wi-Fi client support. This is an easy one, but it's an important one. CURWB doesn't support Wi-Fi connectivity. I can't take my iPhone 11 and connect it up to a CURWB radio. I mentioned CURWB in the beginning was using some Meraki APs to offer that digital divide connectivity. And then on the Cisco Wi-Fi side, that's really what we're all about, providing that Wi-Fi connectivity.
Yeah, so strictly infrastructure.
Yes, that's right. Yep. And then bridge link requirements. So on the CURWB side, you do not need a wireless LAN controller. They have gateways, which I'll talk about, but you can set up a couple radios and make a point-to-point bridge or a point-to-multi-point bridge with 3 radios. And on the Cisco side, you can do that today. We have what's called the embedded wireless controller, or EWC. That's where we kind of take the controller and put it inside the AP, and you don't need a wireless LAN controller. But I got an asterisk on that because that EWC product is not something that we're going to continue. So, several years out into the future, I think that will become more an advantage for CURWB, not needing a wireless LAN controller for some of these smaller point-to-point bridges. And then we get into jitter and roaming. This is where CURWB really shines when it comes to some of the mobility use cases. When you've got, a moving AGV as an example, the jitter and roaming numbers are typically a lot better. And the other thing on roaming is they have a make before break type scenario. So before they move to that new radio, before they roam to that second radio, they're going to make sure that they're connected to it first before they break the connection that they had previously. And the multipath operation, I've got that noted. Mental note there. We're going to get to that toward the end, but I'll explain a bit what that is as well. It falls under the roaming category, obviously. And then mesh. Okay, so mesh is I want to do like a deep dive on mesh because the word is a little bit overloaded, and I want to just kind of clear that up.
Yeah,
so
mesh can mean lots of things.
Yeah, right. And we've got a couple different products here, and one of them was acquired, so it needs a little bit of explanation. So here it is. On the right hand side, we got Wi-Fi, right? And you guys are probably all used to this. This is our a mesh deployment. It's a simple diagram I'm showing. And you've got a controller up there and you've got a wrap. Okay. A wrap is a rooftop access point. It's going to have power. It's going to be plugged into the distribution network via fiber or Ethernet. And then, out there talking to the wrap are these maps. And these maps are going to be, distant APs. They might be on the other side of the parking lot. Sure, they got power, but they have no data connectivity. So the map talks back to the wrap. And sometimes it might talk through another map to get to the wrap. So it's kind of like a multi-hop scenario. And you can think of it as a routing protocol that's kind of running on top of all this. It's called Adaptive Wireless Path Protocol, or AWPP. And what this does is it has metrics, just like a routing protocol, and it figures out what's my best path to get back to the wrap. That's what the map has to do. And it's going to look at number of hops. It's going to look at stuff like receive signal strength. It's going to look at the noise floor. And it's going to figure that out and do it dynamically. And if something changes, well, then it's going to change as well and find an alternate path back to the wrap. Okay. And that's what typically we call mesh at Cisco. It's been around for quite some time. But on the CURWB side, they don't have anything like AWPP.
So, hey Dan, real quick, let me interrupt you.
Yeah.
So I see on the Catalyst mesh side, you mentioned the wrap, and then you have the map connecting to the wrap. But multiple maps can talk to a map to get back to the wrap. There's multiple map hops. Can we do the same thing on CURWB? On the CURWB side?
Yeah, you can, right? So they're going to call it like relay points. For them, the word relay kind of comes into play. But on CURWB, you could have the same thing. And in fact, the new CURWB radios have dual 5 gigahertz. So the way you would take advantage of that is you could have a distant CURWB AP out there on the real distant far side of a parking lot. And then that could talk to, say, another CURWB AP in the middle of the parking lot. And it might use one 5 gigahertz radio for the northbound side of that connection. And then the southbound connection of that AP would then talk, to the other side toward the distribution network. So yeah, absolutely, they can do that. Okay. In fact, if you dig into the CURWB documents, and you're going to come across, now, let me say, focusing on the left side now of this pane, when you dig into the CURWB documents, you're going to come across like a mesh point and a mesh end. And as a Cisco mesh user, you're going to start to think, well, hey, what is this mesh word here? Is this Cisco mesh? Well, no, it's not. It's not exactly the same, but they do use the word mesh. And the mesh point for them is kind of like our map, and then the mesh end is more like our wrap, where it's going to be connected into the distribution network. Yeah, and they have an overlay protocol too that's on top of this. As a Cisco Wi-Fi person, I think of that overlay protocol as kind of equivalent to their CapLap. They're doing some encapsulation too, and they're using MPLS is at the heart of it. It's not straight up MPLS. They've modified it to work well in a wireless environment, and they call it Prodigy. So when you're reading through their material and you see the word Prodigy, think overlay, think MPLS, and it's patented too. So they've got some intellectual property that goes along with it. And in fact, the job of that mesh end there that I'm showing, that mesh end its job is to take the data coming in and encapsulate it into this Prodigy protocol, and then also, of course, on the reverse side of that, to de-encapsulate that Prodigy protocol as well. Special thing that the mesh end there has to do.
Absolutely right.
Yeah. And then, there's also some point-to-point. What I'm showing on the left here is kind of a point-to-multi-point scenario. So the way it works is those APs, and I show two of them, they could be tied directly together via Ethernet cable, or they could be tied together through a switch. But they're running a piece of software that the Fluid Mesh team used to call Titan. And Titan is included in the AP automatically. And, if one of the APs should fail, the other side's going to pick up, within like 500 milliseconds and keep that link going. So that's how they get their high availability on the CURWB side, if it's needed.
Great. So, hey, Dan, so far we've discussed, the CURWB name. We've discussed difference between Wi-Fi and CURWB. Can we dig, and we mentioned this earlier, but can we dig a little deeper into like the fixed side and the mobility side of CURWB?
Yeah. Okay.
Or like use cases.
Let's focus on use cases. Dig in a little bit more to that. We'll let's start with the fixed architecture. Then after that, we'll touch on when things start moving, mobility. And this is where we do have some overlap with the existing products as we've mentioned. And I've got some numbers up there for throughput and distance. Those vary. We're still doing testing on some of the new products. I think with 6 gigahertz, those numbers are going to increase quite a bit. Those numbers are really kind of based on what we were doing with Fluid Mesh. But with the new product set coming out and 6 gigahertz, I think we'll be able to do quite a bit more than that. So this just shows a point to multi-point scenario. And, you've got a CURWB radio plugged into the head end. That would be your mesh end. And then your other radios out there are in this point-to-point configuration are your mesh points. And on the top, you got that scenario where you're providing Wi-Fi connectivity. And keep in mind that CURWB right now today doesn't have a Wi-Fi radio integrated into the AP. So we do need something like a Meraki AP. It could be a Cisco Catalyst AP to provide Wi-Fi services to something like an iPhone
or client services.
Yeah. And, there's lots of different use cases we use here for point to multi-point. And then to give you a little bit of a product introduction here, these are all 9165Ds, D as in directional. And, what that looks like, if you take a closer look, is right here. The nice part about this AP, this CURWB AP, is it does have a directional antenna integrated into the AP. And a lot of times that's all you're going to need. Okay, that's a 15 dBi directional. Now, alternatively, if you wanted to use a different antenna, maybe something that had a different beam width, different azimuth, different elevation, you do have a couple N-type connectors on the top. So you could, use your own 5 gigahertz radio up there, or you could use a 6 gigahertz radio. And it's a 2x2, 2 transmitters and 2 receivers. The reason for that, is that this AP was really kind of designed to work in this scenario. And we find that, when you get into longer distances, especially with some narrow beam width antennas, that you don't get the reflections that you do inside. You don't have that multipath environment. So you can't really take advantage of, say, the 4x4, the 4 transmitters and the 4 receivers. So 2x2 is a nice sweet spot for this type of product. Now, alternatively, there's another product you could also use. It could drop right into this architectural diagram I'm showing. It could be the 9167E. E as an external antenna. This here is a 4x4. Maybe you could take advantage of that at some shorter distances if you're doing some fixed links. Also 6 gigahertz. And keep in mind, 6 gigahertz does require AFC. And that's something that hasn't quite been finalized yet. But as soon as you have external antennas with 6 gigahertz, you have to have the AFC component. So there's got to be a GPS involved, and there's GPSs in each of these APs. Each of these APs is also IP67 rated, so they're ready to go. No additional cabinetry or anything required to put them outside. And the other thing on 6 gigahertz, I think this is an important call out. Something that I kind of missed it, but I was reviewing for this. I was like, oh yeah, I need to tell everybody this. But with 6 gigahertz, it really works out nice for point-to-point and point-to-multipoint links because you got all that extra bandwidth. So we're going to be able to get some really good speeds there. But when it comes to moving assets, when you've got like that automatic guided vehicle moving around, or maybe it's just a pickup truck moving around a shipping yard, 6 gigahertz isn't really certified for moving assets and moving vehicles. Okay, so keep that in mind.
Interesting.
Hey, Dan, I'd just like to jump in here. We've got a bunch of questions here coming in via Slido, and I think this slide probably lends itself best to this particular question.
Okay.
They're asking about how far a CURWB radio can go. Now, I'm sure that depends on the antennas direction, the external antennas and gain and whatnot. But they mentioned something about Wi-Fi mesh being limited to a certain number of feet on the WLC. So I guess, what have you seen customers as far as in their deployments, as far as what they're able to achieve as far as distance?
Yeah, loaded question. Mileage will vary, but to answer it, typically, well, let me say this first. Line of sight. This is line of sight technology.
Yep.
And you're going to have the vertical assets that give you that line of sight. You're going to have to think of things like the Fresnel zone and make sure there's nothing impacting that. All those things, if they're solid, then certainly 3 to 5 miles is feasible. We've done longer distances than that. On the fluid mesh side, they were using some dish antennas with some really high gain, and they were taking advantage of some of the higher EIRP limitations that are in Uni 3, and they were going 15 miles. On the Cisco side, we're not quite there yet. Different world, different regulatory environment, and we're not using those higher gain antennas yet. So I think that 5 miles or less, I think, is probably a good rule of thumb right now. And it becomes really an engineered link when you get beyond that, and you need to have some specialty installation assistance. People that are used to doing this and they've got the tools of the trade to help.
Thanks, Dan.
Yeah. The EIRP still on the newer CURWB products is 36. In the past, fluid mesh would go higher than that on some of the Uni 3 channels. But as I said, on the Cisco side, not quite there yet. Different world, more attorneys, more regulatory stuff we've got to abide by.
So Dan, I have a question too. So you mentioned that it can be a fixed or mobile uh, access point.
Yeah.
It can be a Wi-Fi or curb. That switch, I mean, how difficult is that to make? I mean, what goes into that? Do we have to, is it like a firmware update? Is it a simple CLI command? Is it, what's the process of that?
Okay. Yeah. Good one, Ray. So the 15, the 9165D rather, what I'm showing here, this is a curb only product, no Wi-Fi. Okay. Now, when you get to the 9167E, this is dual persona. It can be curb or it can be Wi-Fi, and you can switch back and forth with a CLI command. It's pretty seamless. I've done it. I like it. The licensing, however, is different. So just understand that and mind your entitlements. I don't want to get into licensing today, but there are some differences there.
Okay.
Yep.
So we've talked about the fixed architecture. Can we move over to the mobile side, the fluidity side? I mean, does that look any different?
Yeah, it does. And this is I got an architectural diagram here. This is where I think Curb really has a nice niche. We can kind of do some of the point to point and point to multi-point stuffs with Wi-Fi. If you've got existing Wi-Fi controllers, that may make sense to go with the Cisco traditional product. If not, then Curb might be a good fit. But yeah, the mobility piece, which I'm showing here, this is their strength, and what I've introduced here is the gateway. So there's some gateways that are being used here in this diagram, and the real purpose of the gateway, it allows the Curb product to scale, and that they can certainly do. The gateway is called an IEC 6400, and typically when you start getting into throughput that's above a gig, or maybe more than 50 vehicle radios, or more than 50 say AGVs, that's when the throughput and the data starts increasing to the point where we do want to introduce these gateways. And what happens is that the go ahead, Ray. I think.
Oh no, I was just going to be a question of mine. Like, at what point do I need that? But you just answered that.
So. Yeah. About 1 gig or greater, 50. That's just rule of thumb. I think it all probably requires more analysis, but rule of thumb, yeah. And the gateway is rated for 5, 10, or 40 gig. And what happens is we talked about MPLS before. And what we do is we now move that encoding and decoding of the MPLS protocol, taking away that outer wrapper. There's some overhead, some compute required for that. So we move that off of the radio and we move that task to the gateway. That helps us scale here. And, in this case here, I've got some AGVs that are kind of on a factory floor at the bottom of this diagram. And, they're all roaming around, and they're using, MPLS, as I mentioned before, to make connections. And MPLS has been modified by Curb, and it is patented. And what we do here is, MPLS is going to have what's called link paths, and it's going to create multiple paths back, to what I'll say home base, back to the distribution network. And it's doing that constantly. And typically those paths in traditional MPLS are updated through a link state protocol, something like OSPF. But to run that on a small compute platform, to run that on a radio poses some challenges. I'm sure there's some cost challenges associated with that. So the proprietary piece, the special piece of MPLS that Curb has, modified is the ability to keep those multiple paths up and running dynamically and be able to do that without a link state protocol, to be able to do that with using neighbor information. And you're probably used to neighbor information if you've looked at radio resource management, which is our dynamic power and channel tuning on the Cisco Catalyst side. That's RRM, and we use neighbor messages there, and that's how they're doing it on the Curb side with MPLS. All right, so they've got all these AGVs moving around that are able to not drop a packet, make before break handoff, very low latency, and they're doing it with a client that looks like this. Okay. On the Wi-Fi side, we are all very accustomed to clients. Clients are one of the challenging parts of Wi-Fi There is an endless limitation of NICs on the Wi-Fi side with associated drivers, and making sure that they're all working and they're working well with the infrastructure is always one of the biggest challenges of Wi-Fi. And one of the things that CURWB has done is they have their own client. Okay, what you're looking at here is a 9165E, E for external antennas, and this is a CURWB client. Okay, it's kind of like the work group bridge on the traditional Calus side, but this is a engineered client that works with the infrastructure. It's not just a Samsung or an Intel client or another client that you happen to find on the shelf at Best Buy. This was designed to work and work well as a mobile client with the CURWB infrastructure. And, it does have external antennas. It's got two 5 gigahertz radios in it. It's also got a 6 gigahertz radio. It can be a work group bridge on the Catalyst side, or it can operate in CURWB mode on the CURWB side. And it's also quite small.
Small form factor there.
Yeah, it's designed to be tucked on the side of an AGV, right?
Hide it away.
Yep. And the other piece of it when it comes to roaming is I talked a little bit about MPLS and some of the unique characteristics of that. But when you get into the RF level, it's also a little bit unique. A Wi-Fi client typically is going to wait until it gets down to, maybe neg 68, might be neg 70. It varies based on all the different Wi-Fi clients that are out there. It's going to wait until the signal gets kind of poor, and it's going to say, oh, okay, I better start doing some probes. It's time for me to start thinking about moving to another access point. CURWB is more, I'll say, deterministic and more proactive about that roam. They are using, of course, a hysteresis. There's a minimum and max on the hysteresis side, but they're going to make that switch quicker, and they're going to do it when that signal is better to make sure that, the MCS rates and stuff stay up, make sure that there's no packet drops. Right, so a little bit different from an RF standpoint on the roaming. And you can do that when you're controlling the client, like a 9165E.
All right, Dan. Well, we're coming down to the home stretch here. So talk to me about interference. This is you mentioned this before. It's an unlicensed, product. So, and we talked about AGVs, and if I lose a couple of packets, I'm dead, and I can't go anywhere. So, talk to me about interference.
So this is part of the CURWB mobility solution. It's called multi-path operation, and if you can envision like an AGV, as I'm showing here, it's roaming around a factory floor. You got infrastructure radios up there on the top. And then you've got this 9165 client, I'll call it, which is I'm also showing here. 9165's got dual 5 gigahertz radios in it. Each of those 5 gigahertz radios can operate on a separate channel. One channel connects to, the one AP, one infrastructure AP. The other 5 gigahertz radio on another channel connects to the second infrastructure AP. And they both send out the same data. And yes, there's some redundancy there. But if there happens to be a problem like interference on one side, well, then there's a pretty good chance, the other side's going to make it. Now we're up to like 99.99% connectivity.
So this sounds awfully familiar. Sounds like, for the upcoming Wi-Fi 7, that multi-link operation, is this the same, similar?
So sure. Wi-Fi 7 is emerging, and they do have similar, but the way it works with that is you've got one Wi-Fi 7 AP. It's got multiple bands, say 2.4 and 5 gigahertz. And a client could talk to that single AP using two separate bands. Very early still for Wi-Fi 7, but that's kind of the way that I think is going to be used. And in this case, contrast this with, two 5 gigahertz radios operating on separate channels, talking to two different infrastructure APs. So a little bit different, but similar concepts. Maybe Wi-Fi 8, Ray?
Right. Who knows?
So
one final question for you, and this is kind of the $1 million question. how is this managed? Is this through Catalyst Center? Is this through, is it a cloud? Is it an on-prem management system? What information do you have on that for us?
Okay, so yeah, we'll wrap it up with this. IoT Operations Dashboard is a cloud-based product. It's used for other IoT operations as well as configuring CURWB from the cloud. So you might start off with your deployment easily using this tool to configure and get all your equipment set up. And then after that, I'll say, you kind of cut the cord and you become air gapped and your equipment operates after it's been configured. You could also do, firmware updates from the cloud if you are not in an air gapped environment. If it's not something you want to use, well, that's all fine. You can configure the radio using a CLI or the integrated GUI. So lots of different options there, but DNA Center, which is probably your next question, Ray, not an option today. We'll get there in time, but separate pane of glass.
Sounds good. Well, that's our presentation for today. So I will hand it back to Mr. Clammert to wrap us up.
Right. Thank you, Ray. Thank you, Dan. Great information here on CURWB. And that's not just me saying it. We got a bunch of questions, and one of the comments too was specifically, thank you for doing this. There seems to be not enough information out there on CURWB. So thank you to our folks who are attending and watching this, and for that feedback. We appreciate that. There is a survey also at the end, so we would appreciate your feedback when you do exit out and close out as well. But I also wanted to just remind people to please subscribe to our YouTube channel. It's youtube.com/@GetUnplugged for more great content. You'll also see this episode post out there if you'd like to go back and review anything. Also, I would like to remind you that you can see what upcoming episodes, if you go to cs.co/getunplugged, you can look at upcoming episodes, their topics, and register for those if you'd like to attend via WebEx that way. Looks like we're good on questions in the Slido. Thank you, everyone. There was a lot of questions, so this is good. It looks like we hit a great topic here, and thanks for the feedback again, like I said. Also, if you have questions afterwards, you'd like to reach out to us, you can always get a hold of us via your Cisco account team, or you can email us directly at getunplugged@cisco.com. Thank you again for watching this episode, and until next time, stay connected and unplugged.